Okay, let us start. Let us start.
Hello?
Yep, hello, let us make a start.
Yeah, can sir. So just give me 1 minute, sir. Sir?
Yeah, faster. You are wasting time already today. You are too slow already.
Why?
Okay,
Yeah, okay, sir.
okay. If you want to mark, as I say, after we have completed the lesson, you just a few days do it and pass it up, send it to me. You want me to mark? If not, you will mark in class.
No, I pass it up to you, sir.
Right? Amplitude, maximum displacement of oscillating particle from the rest position. Mark yourself. Period, time for successive crust to pass a point. Wavelength, distance between successive crusts or particles that are in phase. Okay, either distance between successive crusts or distance between particles that are in phase. Right? Phase, our particle is the stage that a periodic motion has reached with respect to a cycle. Okay, got all that?
Got.
Right, and then the wave speed is speed, the distance per unit time that a crust move. Okay. Right? Phase difference between 2 points that are 2 cm, that one you should be able to do. Right? 90 degrees of pi over 2 radian. Stop me if I'm going too fast. Right? And then you should know all this symbol. If you can get it right, give yourself each 1 point. F is frequency in hertz. V is the speed in meter per second. K is the constant or wave constant. I is intensity. Watt per meter minus 2. A is amplitude in meter. Lambda is the wavelength in meter. Okay, you should be able to do that. Yeah, why am I blocking it? Okay, for C. Right? Answer is A. That's the amplitude. D is the wavelength. Diagram shows the displacement time graph for progressive wave. What's the amplitude of the frequency? Right? Amplitude is 5 millimeter. Frequency can read, right? 20 millisecond. Right? That's your period. You can take 30 minus 10 also can. Then find your 1 over T. 50 hertz. Answer is B. Right? Besides testing you whether you know how to read the graph. Amplitude is about 1 cm. And period, right? This is a period there. 0.25 or 0.249. Right? Round it off. Frequency is 1 over period. And know how to find the speed. Frequency times wavelength. Frequency is 4 Hz. Wavelength, the tone is 2 cm. Sketch the graph, a wave of half the amplitude and twice the frequency. Okay, divide it into quadrant, easier to draw. Half the wave, half, this is about 1. So half is 0.5, half the amplitude, but twice the frequency. Twice the frequency. Okay, that's one frequency. So that should be 2 cycles there. What's the phase difference between P and Q? P and Q, right? You can put angle there, 0, 90, 180, 270, 260. So P and Q, just take it, subtract it. 90 degrees. Right? P and Q, this is your P, this is your Q. P and R, P and R, P and R is here. Okay, 270 minus 90 is 180 degrees. Okay, what's the frequency? This is a pressure time graph, which we'll study in the next topic. Diagram below represent the variation of time of the pressure at a point in air through which the sound wave is traveling at 340 meters per second. What is the frequency of the wave? Okay, should be able to calculate the period is 200 microsecond. Convert it to SI unit. F is 1 over T. Put in your value and calculate out. Frequency is that. Answer is B. Maximum velocity. At which point is the maximum velocity of the particle? Okay. So you should be able to say where is A in this oscillation. This is a displacement. This is the max amplitude A. So where is the particle at A? You should be able to identify on the vertical scale. Okay, there's your A there at the start there. So maximum velocity, right? Maximum velocity can take the slope there. Maximum here or maximum here, or it can be here at F or can be at H also. Zero velocity, right? We are looking at the particle, not the wave speed. Particle. So particle, you take the gradient. Gradient at E and gradient at C and G is 0. Right? A or E. Kinetic energy is maximum. Right? Where the velocity is maximum. No? B, D, F. B or D. Maximum acceleration. Right? Remember this simple harmonic motion. So where the displacement is maximum, the acceleration must be down there. No? Right? So it's at A or E. Same. Or it can be C and G. Okay, are you all right? Anything not clear?
Okay.
What is the phase difference between A and B? A and B, 90 degrees or pi over 2 radian. A and C, right? A and C is 180. E and G, 180 also. Right? This one you won't bother lah. This one is either you read here or you read this point. Right? So it's either you read this angle, which is this one, or you read here and here. Same thing. Right? They didn't ask you lead or lag. So either you read this angle theta or 360 minus theta, same thing. So answer is C. What's the phase difference between the oscillation? Okay, you should tell me the answer for this one. Yep. What's the phase difference? Yep. What's the phase difference? Yeah, from here to here is 90, pi over 2. So you change it to 4 pi over 8. This will be a 1/8. Oh. Right? Put an angle there, then you can read. Right? This is 0, this is 90 or pi radian, and this pi is 180. Right? You will concentrate on this curve. This is 180. This is 180 here. Right? And then sorry, slightly out. 270 will be here. 360 will be here. Let me just adjust that. Okay, that's all. So phase difference, you just read the angle, that's all. Okay, so if this is 90, then this one will be 45. No? 45 is pi over 4. Sorry, no, it's pi over 8, pi over 4. Right, just now I read wrongly. This is 90. 90 is pi over 2 here. So pi over 4 will be here. Answer is A. No? Okay. Are you with me?
Yeah.
Sound wave of frequency 400 Hz is traveling in gas at a speed of 320. What's the phase difference between? Right? This one we have done that already. What's the answer? You've not been doing your homework. Right? Calculate your wavelength first. Right? Given speed, given frequency, calculate your wavelength. Right? Then use the appropriate formula. This formula, calculate that phase. Okay. A wave motion has an equation that where x and y are in meters and t in second. Which direction is the wave traveling? You have to tell me. Direction is the wave traveling. Right? So you do your homework, that's why I can see traveling in a negative x direction because it's positive here. Amplitude 0.4 meter. Wavelength, calculate out. K 2 pi. K is this one. Lambda, take the 5 down. Frequency 2 pi f. This is 2 pi. Right? There's your omega. Speed. Okay. Any comment? If not, let's carry on. Okay, let's go to intensity. Okay, you should be able to read the graph. Which row shows the intensity and frequency of ratio of x and y? Okay, that's how you calculate your intensity. Right? So intensity is you want x over y, iy, ix over iy, right? Ka square. It doesn't matter. 4, that's your 4 square. And then this is 2 square. So 16 divided by 4 is 4. And frequency, right? Frequency is one of the period. So for x is about 1.8 there, estimate. And y the period is about 3.6. Just estimate, this is about 3. Right? So it's about 3.6, we are not sure. Right? Doesn't matter because you are looking for objective one. So you get 2. The answer is donkey. Can? Okay. 14. Wave amplitude A has an intensity of 3.0 cm. What is the intensity of wave of same frequency that has amplitude of 2A? Right? Intensity is proportional amplitude square, or intensity is 3. K is a constant. Amplitude is A square. And new intensity K, double the amplitude, double that, square that, so it's 4. Right? K square is 3, so 4 times 3. Right? We have done in class. So it's 12. Okay. So you should be able to do that. I is Ka square. I, right? Double the amplitude is 4Ka. So replace the Ka square with I. So it's 4I. Same thing, just repeating the sum. Instead of amplitude A square, amplitude is 3A over 2 square. So it's 9I, right? A square over A square, Ka square is your I. Right? 3 square is 9, 2 square is 4. And if the intensity is 2I, what would be the amplitude of the terms? Right? So that's a basic one. So let the new amplitude, there's a new intensity, new amplitude, A square, Ka square, I is that one. So your A, K and K cancel out. Square root of A is square root of 2A square, so it's A root 2. Okay or not? Okay. Right? It's just getting you to familiar with a formula, that's all. Right? You are given intensity, what's the rate of energy? You want to find P, use the right formula. Right? P is I times A, or I is P over A. I is 20. A is that. Okay, out. If the intensity at point X for the source is I, what's the intensity at a distance 2x from the source? Okay, go to the formula. Right? K is a constant, x squared. New intensity, K divided by K divided by 2, 2x the whole thing square. So it's, right? K over x squared is I, and this is 2 square. 2 square is 4. So it's a quarter intensity. Okay, what's the answer for this one? Donkey. Right? Can either work out or remember the equation. That's your 3. Intensity, that's the amplitude. Find your K. And from here can calculate your K, or new one, new intensity, that's the amplitude, 0.4. And 2 divided by 1. Right? So you got I1 divided by 3. K and K cancel. So it's 0.4 square divided by 0.2 square. So the answer is 4. Okay, 12 watt meter minus 2. Okay, let's go to number 18. Sorry, this morning take a bit too long. Too many problems. Yeah. That's why I don't like the 2-hour class. Usually I want to break it out into 1 hour.
Yes, Chair.
Yeah, let me download it. Yeah, why it takes so long one?
Chair, maybe the extra half an hour left, right? There's another half an hour left, right?
Ah,
Can I replace it next class, make it 1.5 hours? I think too long already, lah.
okay. We will finish the last part.
Yeah, maybe today 1.5 hour lah, then the next class 1.5 lah. Too long already lah, Chair.
Okay. We will finish a few things a bit more. Very slow rather. Okay, let's go to continue on the other part. Sorry to keep you too long this morning. Okay, number 18. Go over very fast. For transverse wave, what is the wavefront? Right, it's just a line. Answer A. Right, a phone ring and lights up. Which type of wave? Right, light is transverse, sound is longitudinal. That one you should know your STPM work. C. State the condition for standing wave. Right, memory work. Same type of wave, moving in opposite direction, same medium, same amplitude, same speed, same frequency. Take two difference between standing wave and progressive wave, memory work. In standing wave, the nodes are points that are permanently at rest. Progressive wave, there's no point that's permanently at rest. Every point is oscillating. Okay, refer to your note for the other answer. Right? Nodes are points that are permanently at rest, while antinodes are points oscillating with maximum amplitude. In terms of wavelength, what is the distance between successive nodes? Right? How wavelength? Between a node and antinode, a quarter wavelength. Stop me, I'm going too fast. Right? This one is just to get you to understand what is superposition. Right? Where this one crossover, that's what you get. The center part as right, double. The other part is still the same. Whereas this one, this part cancel off. This part still there because 0 plus 1 unit. Right? That way, this part will add on to here. This part will just carry on from there. That way, right? Where this part is the same. This part will cancel off. And this part will still be left. Okay. So it doesn't cancel. We just add the two together. This part is 0, it will be maximum. This part is 0, it will be maximum. Then you join the two parts. Right? This one is just to same thing, principle of superposition. Right? Just add them up. That's what you get. Right? This is 2a. This is 4a. 4a plus 2a is 6a. Right? Just plot some points and then draw. Frequency doesn't change. So amplitude is 6a. Intensity, you should be able to work it out, 36. Right? Double that. Double that. Intensity will be double that. Right? That's how you add. 2 plus 4 is 6a. Or when the show working, there's the initial one. I is ka squared. Right? Amplitude is 6a. There's 36. Right? Ia is I. That's all. Okay, this one should be able to read. Wire is stretched over two support Q and R at a distance 4x apart. The three light pieces of paper rest on the wire as shown. When the wire is made to vibrate at one particular frequency, the middle piece of paper stays on, but the other fall off the wire. What is the wavelength? So you should be able to say, okay, middle piece stay on. As right? That means this must be a node. It's not vibrating. Whereas this thing is vibrating. That's why the paper is right, displaced, and then it will be, because it's vibrating, it will lose its contact and then fall off. Okay, so you should be able to draw. There's your standing wave. Another loop down there. Right, so wavelength is 4x. Okay, answer C. A string is stretched between 2 points. It is plugged at the center of the string and vibrate. Length is 76 cm. So state the wavelength. Right? So you must be able to recognize this half a wavelength. So wavelength is 2 times 75. Okay, 150. Right? You are given the frequency, calculate the speed. I think you to use a formula. F is F times lambda. By reference to formation of standing wave on the string, explain what is meant by the speed. What is this speed? This speed is the speed of the two progressive waves in opposite direction. Okay, that's how we form standing wave. The speed is the speed of the two progressive waves in opposite direction. Okay, what's the answer for this one? Right, we have finished it off with this last one. Then you can evaluate yourself how well you do. What's the answer? Right, A is wrong. This is not the largest amplitude. Largest amplitude is
Why
here.
is the answer?
P and R vibrate in phase. Yeah, P and R are in phase. S is an antinode. No, S is a node. Horizontal distance between R and S is how a wavelength? R and S, this is one wavelength already. Plus another, probably, very hard to estimate. Probably 1/8, right? So it's wrong. Okay, P and R vibrating in phase. P and Q is 180 degrees out of phase. S is a node. R is an antinode. right? Vibrating at maximum amplitude. So answer is B. Okay, anything else to ask? I will stop here. You carry on the other half hour next Friday. Anything you want to ask?
No, so far nothing, sir. Just scared of physics, lah, sir.
Say again.
Just scared of physics.
Self physics because you don't put effort to learn. I teach you little bit, hoping you will try the formula and force it in, but you don't want. So of course you don't learn, you become more frightened because you don't know how to solve the problem. Right? Yeah, come to attend lecture, it won't help you unless you put in the effort. I'm saying you don't put in the effort. I break it down to small portion to let you work with the formula, but you don't bother. Okay, so you better do something. If not, you are going to lose out. Okay, I'll stop here.
So 1.5 hours today, right, sir?
Okay.
Yeah, there was another remaining 30-minute class, so next week replace lah, sir, I guess.
Okay. You replace that on
Okay.
next Friday.
Okay, 1.5 hours replace lah, sir.
Yeah.
Make it 1.5. Okay, thank you.